day, grade 8 learners. This is Teacher Karen, your teacher in Mathematics 8. Before we begin, make sure you are in a comfortable place and can clearly hear me in your radio or see me in your screen. Have you taken your snacks? It is very important that your stomach is full and your body is in good condition, so your mind is alert and ready to listen and understand the lesson we are going to discuss today. At this point, please get your module in Mathematics 8 for the lesson Illustrating Rational Algebraic Expressions. Again, I repeat, our lesson for today is Illustrating Rational Algebraic Expressions. Let's start! Our lesson for today is all about rational algebraic expressions. At the end of the lesson, we're expecting you to define, identify, and evaluate rational algebraic expressions and relate rational algebraic expressions in real-life situation. The speed of a running motorcycle can be computed by the ratio of its distance traveled and the elapsed time. How can you write this into mathematical expression? In your previous grade level, recall that ratio shows the comparative sizes of two or more values such as 1:4, which can also be written in fraction form 1/4. Other examples of ratio in fraction form are 1/8, 1/3, a over b, or x over y. Let us start this lesson by reviewing the concepts in translating verbal phrases to mathematical expressions and identifying polynomials which you had learned in your Mathematics 7. Let's match the verbal phrases in column A to the corresponding mathematical phrases in column B. Let's have number 1. The sum of a number n and 9. Its mathematical phrase is found on letter C, the sum of a number n and 9. Let's have number 2. The product of n and the number 8. Its mathematical phrase is found on letter F, the product of n and the number 8. Let's have number 3. The ratio of distance d and time t. Its mathematical phrase is found on letter D, the ratio of distance d and time t. Let's have number 4. The difference of a number n and 21. Its mathematical phrase is found on letter B, the difference of a number n and 21. And let's have number 5. The cube root of a number n decreased by 5. Its mathematical phrase is found on letter A. The cube root of a number n decreased by 5. In translating verbal phrases to mathematical phrases based from our examples, we have considered the words sum, product, ratio, difference, and decreased. Sum, same with the words plus, increased by, combine, and more than, indicate addition. Thus, we use this symbol. Product, same with the words times and multiplied by, indicate multiplication. Thus, we use this symbol. Ratio, same with the word quotient, indicate division. Thus, we use this symbol. Difference, same with the words decreased by, less, minus, indicate subtraction. Thus, we use this symbol. Will you consider these mathematical phrases as polynomials? Why or why not? An algebraic expression involving only positive integral exponents and containing no variable in the denominator is called a polynomial. Positive integral exponent means the exponent is a positive integer. Therefore, the sum of a number n and 9, the product of n and the number 8, and the difference of a number n and 21 are examples of polynomials, while the ratio of distance d and time t and the cube root of a number n decreased by 5 are non-examples of polynomials. What expression can be formed when you write two expressions from the examples of polynomial in fraction form? Irrational algebraic expression is an expression that can be written in the form p over q, where p and q are polynomials, and q must not be equal to 0. In other words, irrational algebraic expression is an expression whose numerator and denominator are polynomials. How will you know that the expression is a rational algebraic expression? For you to recognize rational algebraic expressions, examine the following examples. We have 6 over the quantity x less 3, the quantity y squared less 1 over the quantity y cubed less 3, and the quantity 18n plus 1 all over the quantity n squared plus n less 2. All of these expressions are rational algebraic expressions, since these contain polynomial expressions in both numerator and denominator respectively. Check these expressions. The quantity 3x less square root of y over 5 square root of x. The quantity 3x less square root of y over the quantity x plus 6. And the quantity 2x raised to negative 2 less 3 all over the quantity x plus 6. All of these expressions are not rational algebraic expressions, since the expressions contain irrational numbers such as square root of x and square root of y, and a variable having negative exponent such as x raised to negative 2, which are not polynomials. Remember, in identifying whether the expression is a rational algebraic expression, the expression must be in a fraction form. The expression must have in its numerator and denominator a constant, a variable, or a combination of both that are polynomial expressions, and the expression must not have a negative exponent, a radical sign, or a fraction exponent in the variables in both numerator and denominator. Recall that the rational algebraic expression is a fraction containing polynomials in both numerator and denominator, provided that the denominator must not be equal to 0. The denominator cannot be 0 because a division of 0 is undefined or meaningless. In rational algebraic expressions, you need to pay attention to what values of the variables that will make the denominator equal to 0. These values are called excluded values. How are you going to determine the excluded value in a rational algebraic expression? We have steps in determining the excluded values. Step 1. Let the expression in the denominator be equal to 0. Step 2. Solve the equation to determine the value of the variable. Let's have illustrative examples that will help you understand it better. Let's have example number 1. Identify the value of x that will make 6 over the quantity x less 3 undefined. Step 1. Let the expression in the denominator be equal to 0. That is, x less 3 is equal to 0. Step 2. Solve the equation to determine the value of the variable. We have x less 3 equals 0. So we have x less 3 equals 0. Adding 3 to both sides of the equation, we have x less 3 plus 3 equals 0 plus 3. That is by addition property of equality. Simplifying this one, we will have x plus 0 equals 3. Then we will get x is equal to 3. This means that when x is equal to 3, the expression 6 over the quantity x less 3 is undefined. Thus, x equals 3 is an excluded value in the given rational algebraic expression, or in other words, x cannot be 3. What happens if you substitute 3 to the expression? We have the expression 6 over the quantity x less 3. If we substitute 3, we will have 6 over 3 less 3. And we will get 6 over 0. Since division of any number by 0 is undefined, therefore, 3 is an excluded value for this rational algebraic expression. Let's have example number 2. Identify the values of n that will make the expression the quantity 18n plus 1 all over the quantity n squared plus n less 2 undefined. Let the expression in the denominator be equal to 0. That is, n squared plus n less 2 is equal to 0. Let's solve the equation to determine the values of the variable. So we have n squared plus n less 2 equals 0. Let's factor n squared plus n less 2. The factors are n plus 2 and n less 1. So we will have the product of n plus 2 and n less 1 equals 0. Through zero product property, let's equate them to 0. We will have n plus 2 equals 0 and n less 1 equals 0. Let's solve first for the first one. N plus 2 equals 0. By addition property of equality, let's add negative 2 to both sides of the equation. We will have n plus 2 plus negative 2 is equal to 0 plus negative 2. Simplifying this one, we will get n is equal to negative 2. Let's solve for n less 1 equals 0. By addition property of equality, let's add 1 to both sides of the equation. That is, n less 1 plus 1 equals 0 plus 1. Simplifying this one, we will get n is equal to 1. This means that n cannot be negative 2 nor 1. What happens if you substitute those values to the expression? We have the expression the quantity 18n plus 1 all over the quantity n squared plus n less 2. If we substitute negative 2 to n, we will have 18 times negative 2 plus 1 in the numerator and negative 2 squared plus negative 2 less 2 in the denominator. Simplifying this one, 18 times negative 2 is negative 36 plus 1 all over negative 2 squared is 4 less 2 minus 2. Simplifying further, negative 36 plus 1 is equal to negative 35, that is on the numerator, and 4 less 2 minus 2 will get 0. So our final answer would be negative 35 over 0. If we will substitute 1 to n, we have the expression the quantity 18n plus 1 all over the quantity n squared plus n less 2. we will have 18 times 1 plus 1 in the numerator and 1 square plus 1 less 2 in the denominator. Simplifying this one, we will have 18 plus 1 all over 1 plus 1 less 2. Our final answer would be 19 over 0. Since division of any number by 0 is undefined, therefore, -2 and 1 are excluded values for this rational algebraic expression. You can verify that if the excluded value is substituted in the expression, it always ends up to division by 0. You have to bear in your mind that there are some values that will make the expression defined too. How are you going to inspect it? The process is called evaluating the expression. Let's have example number 1. Let's evaluate the expression the quantity y squared less 1 over the quantity y cubed less 3 when y is equal to 2. Let's have step 1. Let's replace the variable y with the given value. We will have the quantity y squared less 1 over y cubed less 3. Substituting it, we will get 2 squared less 1 all over 2 cubed less 3. Let's have step 2. Let's simplify the numerator and the denominator. We have 2 squared less 1 over 2 cubed less 3. 2 squared is 4 less 1 all over 2 cubed is 8 less 3. That will give us 3 over 5. Thus, when y is equal to 2, the expression the quantity y squared less 1 over the quantity y cubed less 3 is equal to 3 over 5. Try applying rational algebraic expression in real-life situation. Consider these illustrative examples. Example number 1. Vanessa can finish writing a module in X hours, while his brother Ryan can finish writing the same module in Y hours. Write an expression that will illustrate their rate of work to finish writing the module. This can be illustrated using a table. Vanessa can finish the work in X hours, while Ryan can finish the work in Y hours. You can represent 1 over X for Vanessa to accomplish a work per hour since she can finish writing one module alone in X hours. On the other hand, you can represent 1 over Y for Ryan to accomplish a work per hour since he can finish writing one module alone in Y hours. Let's have example number 2. The area of a rectangle is x squared less 121 square units, while its width measures x plus 11 units. Illustrate a rational algebraic expression in finding the length of the rectangle. Recall that the formula in finding the length given the area and the width of the rectangle is length equals area of a rectangle over width. Substituting the area and the width of the rectangle, we will have the quantity x squared less 121 over the quantity x plus 11. Then the length of the rectangle can be illustrated as the quantity x squared less 121 all over the quantity x plus 11. There are many ways to illustrate real-life situations depending on what technique interests you most. You need to develop your understanding about illustrating rational algebraic expression through accomplishing the activities on your module. I hope you have understood our lesson for today. If not, you can text or call your teacher for questions or clarifications, or you can message them through your group chat, Messenger, or Facebook, if available. Be sure that you will finish all the activities in your module so that you can submit on the scheduled time. Be sure to tune in on our School on Air every day at scheduled time at DWND-FM 88.5 kHz or watch on CMD Cable Television or watch on Kawayan City Division Facebook Live. Once again, this is Teacher Karen, your teacher in Mathematics 8. Tolstoy once said, "A man is like a fraction whose numerator is what he is and whose denominator is what he thinks of himself. The larger the denominator, the smaller the fraction." Have a great day and stay safe, everyone.